Very good afternoon to one and all, and we are here to listen his research experiences of our Honorable Vice-Chancellor, Professor Gurmeet Singh. I would request our HOD to welcome Professor Gurmeet Singh, our Honorable Vice-Chancellor, with a small bouquet. So now I will request convener of this event, Professor Tharnika Rasu, Director of Research, to introduce the speakers.
Yeah, thank you, Professor Suraj. Respected Vice-Chancellor and all the statutory officers, deans, heads, faculty members, teaching and non-teaching officers, staffs, students, ladies and gentlemen, all of you, good evening. So it is very difficult to introduce a person who I know him for the last 20 years. From 2003 onwards, I know him. So I have been working him with for 7 years. So in fact, I know his guide also. He was also my colleague. So I work with him. I know him very well. So for 20 years, another interesting thing is I belongs to chemistry discipline. So I know his what are the research and teaching expertise also. Anyway, I will try to be brief. So the organizing people, they told me to be brief. So I am happy to introduce Professor Gurmeet Singh. Yes, sir. But still there are many people, we are outside, so they should know you also, because then some of the, I could see new faculty members, they joined also recently. So I thought I will introduce. I think they are also recording, so I feel I should give the proper introduction. So Professor Gurmeet Singh did BSc Chemistry Honours from St. Stephen's College and MSc also from University of Delhi, St. Stephen's College, and a PhD from Department of Chemistry, University of Delhi. And he did PhD with Professor Amarnath Maitra in the year 2079. From 2073 to 87, he was working as a lecturer in Delhi University, then associate professor. Until his retirement, he was a full professor in the University of Delhi, Department of Chemistry. And his area of expertise is corrosion inhibitors, then copper corrosion, nano layer deposition and its characterization, smart electrochemical devices for energy and sensing devices, thin film growth chemical and electrochemical method, semiconducting nanomaterial and electrochemical green energy and storage, and nanocomposites based carbon and conducting polymers. These are his fields, and he has received many awards. To mention few, Meritorious Contribution Award from Defense Institute of Advanced Technology, and then Annapurna Award from Society for Advancement of Electrochemical Science and Technology. Then he was invited chair professor in Lunghwa University, Taipei, Taiwan, and then he was awarded prestigious IAM award medal from International Association of Advanced Material. He was awarded visiting professorship for Japan Advanced Institute of Science and Technology. So these are some of the awards, and then he has many public service, university service, and then the administrative service in the Delhi University, and he has been a NCC commissioned officer in the naval wing of Delhi University in the rank of lieutenant commander, and he was member of NCRT group involved in making lessons, TV lessons, and then he was proctor, deputy proctor, provost in one of the important hostel in Manasur hostel, and he was officer on special duty for Deshbandhu College, University of Delhi. So he was chief election officer for conducting Delhi University Student Union. That time even voting machine was introduced during his time only for conducting student elections. So he was fellow SEAEST, governing council member of SEA, AEST, fellow Electrochemical Society, and then member of Royal Chemical Society, London, member of Indian Association of Solid State Chemists and Allied Scientists. And you can see he has been in this field, and he has also contributed a lot in the field of corrosion science. So he has guided more than 15 MPhil and 50 PhD students, and he has published more than 150 research articles in this field, and he has also got many sponsor award in the tune of 7.5 crores for in this field. So it is very difficult to completely read, but I do not want to take much of your time. So I welcome Professor Gurmeet Singh for his delivering his public lecture. Thank you.
Thank you very much, Professor Thrani, for some good words about me. And Dr. Suraj Sinha came to me, he said, "Sir, why don't you give a talk in your own area?" I said, "Well, I can always do it. That is not a problem, because all along we have been working in this. So any day you suggest." But then that day we were not able to work out. Something or the other will keep on happening. So ultimately the day came, which is 1st June, today. And I was wondering what to give, what to talk about. I wanted to talk about something which is going to be extremely useful to everybody. Everybody, non-teaching, teaching, whosoever comes into this. And I'll just put it in one way, one sentence, that when you attend to this talk, the relevant part for all of you, you would be able to save about 30% of your annual budget that you spend on your household maintenance, whatever way you put it. And that's a substantial saving. 30% you save, and by word of mouth, it is spread further, and the amount of saving ultimately it will result is it's anybody's guess. So that's what I thought I'll originally put it. But then I thought at the same time, people would think, is he going to tell us about savings, or is he going to talk about some science or some meaning, some useful thing? So I decided, I'm basically an electrochemist, let me tell you. Electrochemist is one who is into chemistry but deals with electric current. And I was the proctor of the university for a very long time. And I used to deal with the students with a pat at the back, but with a ruthless sense of the word. And they said, why is it that people are very scared of him? The answer used to be given was, look, he is a very well-known electrochemist, and he believes in giving electric shocks. And because of those shocks, people run away from him. And that's probably helped me in keeping what you call the dangers at bay. And I could walk into any number of groups agitating, whether it was of teachers or non-teaching or students. As many as 200 plus at the dead of midnight, 2 o'clock, 1 o'clock, I would walk into them and argue with them, and people will tell me, the security fellows, "Sir, why don't we come along with you?" I said, "No, I'll go alone." And I would walk into them, argue with them. Probably the reason was that they knew that electric current flows in my body, and at desire, at will, I will make it 120 volts, 220, 440, 880. So depending on that, people would get a kind of a repulsion from my body, and they will not come near me. That's the benefit of electrochemistry. Now when I entered here, whenever I've been giving talks like this, I always find a fair number of people. But when I entered now, I got a feeling as if it is my farewell function, that they are all in, which I realized it is not. It's a talk I am giving. So that's what it is. And electrochemistry, as the word will suggest, is a science which deals with electric current with chemistry. Electric current in chemistry, electric current for chemistry, whatever way you want to put it. Maybe some English people would like to give more connotation to this, but it is a combination of electric current and chemistry. That is what it is. Now, most of you would be wondering that why are we going to be getting bored with this kind of a talk? Electro current and chemistry, what have we got to do? Well, you all have to do with your maintenance of the house. You all have to do with your cars, scooters, whitewashings, your clothes, in and around whatever you have. You all have to deal with that. And there, if you are going to waste a lot of money, I suppose we are all going to be concerned about it. Electrochemistry is, as I said, I'll not introduce too much of science. There'll be very basic minimum science. Even a person who has never studied science and is in a hardcore subject like Hindi poetry will also be able to appreciate what I'm going to say that. But I will tell you where exactly electrochemistry comes in. People would not have talked about electrochemistry in the real sense of the word, and those who are chemistry friends who are in the auditorium today, I'll have the occasion to tell you probably this you would have never conveyed it to your students. But now you will realize, oh, this also is there. I'll tell you about that. So when we look at electrochemistry, there are many facets to that. One of the things which is one of the earliest in this subject is photoelectrochemistry. Photography we all do. You have used those old days cameras. That also has to do something with this. You expose for a little more time, you find what would happen to the photograph. Expose a little less than that, you know it will be so light that you will hardly be able to make out whose photograph this is. But then that's the original side of it, the initial phase of electrochemistry. Then gradually we came down to semiconductors and photoelectrocatalysis. I will not dwell on that, but I'll definitely tell you in between what are these. Then there is a thing called organoelectrocurrency. There are many organic chemists in our department, and they would be using electrochemistry for synthetic work, and majority of the good synthesis which has been done of late, something called, if I tell you, electron transfer reactions. One electron transfer reaction you have all known, but two electron transfer reactions when you talk about that inner sphere mechanism and outer sphere mechanism, that is where a lot of electrochemistry will come in. And a thing called perpetual reaction carrying out, which is unimaginable, unthinkable, something perpetual. Yes, it is there, and that is what you find in those. So I have just enlisted there, just for the reason that one should not say, what is it? He is a chemist of long standing, doesn't know basic, no science in this, he's only talking about other things. So I thought I'll tell you that electrochemistry is not only philosophical talking, it also has a lot of scientific concepts. So I mentioned here, conducting organic polymers are there, then doping into that is done. Doping is adulterating something, and we are all very used to that. Adulteration in our life, in our characters, in our society. So it is something like that. Therefore, I'll move further. Then electrochemistry in material science, that is where my domain is this. I essentially deal with smart materials which will be used for energy storage. And if you are able to store certain energy in some material, we can use that for ultimate devices like fuel cell is one, semiconductors, supercapacitors, batteries, rechargeable batteries, all those is the domain which comes into this, and we have done fair bit of work in that. But I will not have the time to give you details of this, and neither would I like to bore you with some movement of electrons, and your brain will also feel little disturbance. Where is the electron? We have never seen. Then I have written charge transfer, surface, and civilization. I'll talk about it for about a minute. Second is corrosion. That's the area where I started with, where I am continuing to be working in. And I've been highlighting everywhere, wherever I go, that those who complain that we could not do good research because we never had facilities. Let me tell you, those who are here in the department, physics, chemistry, geology, whatever, you can do remarkable work without having anything. I need only three things: a weighing balance, some glassware, whatever, test tube, beaker, whatever you can have. And that's about it. Acid, alkalis, everything is there. Rest, you don't need anything. I will tell you how you can carry out very good work, because Pondicherry University has lush green campus. There are a lot of wonderful trees. Some of them are rare trees, and if you can extract something out of this, it can be used very effectively for corrosion, ultimately resulting in wonderful papers. Then inhibiting corrosion, one of the major aspects or aim is going to be to inhibit, to minimize corrosion. That is what ultimately I'm going to come down to. Then we have conversion of electricity into storage devices, or storage and then electrochemical related concepts. You have fuel cells, you have electrochemical engines, all these things are in and around you. There is nothing that I'm talking out of air. You have seen electrical vehicles, you have seen electrical cars, you have seen hybrid cars which are running on electrical motors as well as petrol. So those are there. Then hybrid and batteries and fuel cells, these are other models which are there. Then energy storage, and finally electrochemical capacitors as energy storage. If physicists are there, there is a Organoelectrocurrency plots which would have been teaching how best the discharge is going to be taking place if you draw too much of power out of something. Then we have bioelectrochemistry. This is the latest. One would say, why should we study electrochemistry? Well, this is a very evolving stage of the subject, where we have reached a stage where bioelectrochemistry is also involved. Your ECG. Had this not been there, I don't think you would have ever measured the pulses of what is happening inside. So I have written this question, why should electrochemists be interested in amino acids, proteins and DNA? All those who are dealing with life sciences would know that these three classes of compounds are very important, therefore electrochemistry obviously becomes very important for them. Then in the science of cells, membrane and mitochondria, then conduction in biological organisms. Since it is there, we are able to use electrochemistry there. Then mechanisms in nervous systems, electron transfer in solid proteins and other things, chemical signaling, then electrical signaling, enzymes, all these cardiovascular diseases. If electrochemistry had not been there, I don't think whatever advancement we have done in terms of our cardiovascular treatments would have been there by now. But luckily it was there. Then microbial effects are there, which will be, you have seen manhole where our human beings are getting into that, and it results in at times a lot of deaths also. Why should a man be going into hole? It's a very funny idea, but then man in the hole doesn't appeal at all. So why can't we have something else? Japanese have designed robots that they get in and clean, but we have our electrical systems by which you can change the chemical structures, poisonous gases, and one can safely pull them out by a normal pump. So electrochemical growth of bones. Previously, we have heard about bone implantation, but we have never heard about bone being grown into a human body. That has been possible with the help of electrochemistry. So if somebody wants to get into this field, it is a remarkable area, because you will not come across a human facet where electrochemistry will not be involved. That is why I rightly titled the talk as Electrochemistry in Daily Life. Finally, we come down to the environmentally oriented electrochemistry, which is equally important these days. So global warming, if you talk about this subject, is going to be there. Hydrogen storage is going to be involved into that. That is electrochemistry. We are talking about cold fusion. Let me tell you, one hydrogen joining with another hydrogen will generate so much of energy that an average household can be run for 1 full year, just 2 atoms. And let me tell you, 1 gram mole will have millions, 6 into whatever, raised to the power 10 to the power 23 atoms or molecules or whatever number. You combine the two, so much of electricity will be generated. But that's the catch. How do we do it? To do that, we need to go to the atomic bomb or whatever you have learnt of, the kind of devastations which we have seen. But cold fusion is another area. Now people are talking about it. Suraj Sinha came to me that this is a project he is designing, and if it works out, I said if it works out, it's going to be a great wonder, but then there are certain question marks which probably somebody can sort it out. Then that is what I'm saying, in water splitting, cold fusion you call it, electrolysis of seawater, then electrochemical transport system and electronically powered cars is going to be another thing. you would have never heard of, you would have never imagined that from petrol cars, we'll come down to electrical cars, and then from there we'll move on to something which is going to be not using conventional batteries or the kind of batteries that we have heard of, those small ones. Now we are going to nano stage batteries where even a child will be able to lift and replace it with something, and those cars are also there. That is why Middle East is losing its importance now. People are not bothered about oil sector, and that's where Middle Eastern people are very much worried that our importance in the world will go down. But that's a matter of politics, which also we have been talking about. So indirectly, electrochemistry is out there also. So political science, political electrochemistry will also be an area where probably I think I'll write a paragraph or two somewhere. Then we have fixing of CO2, removal of waste, bacterial effects, electrochemical sewage disposal I was talking about, electrochemical decontamination of soil, soil remediation. All these things are the ones where electrochemistry is used. Finally, which you are very familiar these days, we have replaced all over our normal conventional 100 watts bulbs with LED bulbs. All over, tube lights have been replaced with that. What is it? Do you think it's a very old discovery? No, it's just 10 years back somebody in Japan did that. And there are a lot of those elements. I'm not going to give you the scientific things, 4F and 5 block elements. Only 3 have been used, and we have come out with this. Many others are being used. In our Indian context also people are using that. Don't be surprised if we come out with these devices, the life of which will be 1,000 years. That is being worked out now. And they'll be as hard as diamond. You will not be able to break it. So if that comes in, where are we heading to? Probably it is for all of you to guess. So this is the introductory part of electrochemistry in daily life. Electrochemistry is not only getting a shock, that you touch wire and you get a current, and you get a feeling that is very dangerous. Electrochemistry is something which one has to fall in love with, and then even if you get a shock, you enjoy that shock. And this is what we find in daily life also. When you are in love with somebody, and I don't know, you would have experienced that. When you touch the person first time, you do get some kind of a shock in your body. And that shock, then you realize that one should get it repeatedly. So this is all over. I'm just putting it this way. So we go down further. One of the important areas of electrochemistry is corrosion. This is where I thought I would like everybody to be paying attention on. And if one pays attention, you will be able to save about 30% of your annual maintenance. This is one aspect of electrochemistry. Many others I have listed here. When we get time sometimes else, I will talk more about LEDs, colored LEDs, what are we going to have in, and what is going to be the future, electric cars, the supercapacitors where we have worked, those materials. There is a thing called graphene which people have been using these days all over the world. 90% of the papers are in that area. But many of you would not have realized that if graphene, you put holes in that, it's called lacy graphene. We have worked and we have brought out a number of papers. The storage capacity of that improves 1,000 times. Something very amazing. And if you add certain other materials in that, in those holes, the improvement will be tremendous. So these are things which are on all over. And where are we heading, we do not know. That is why I made a comment 3 days back in one of these seminars in Shri Aurobindo Ashram, when we were talking about new education, national education policy. I said the way things are improving, the way things are being researched into, you don't know how fast things are changing. And all those who are listening there, I said you do not know, 2/3 of these people who are listening will not know what job they are going to be getting into. Though they are working in chemistry, in physics, in computer science, they don't know whether they'll be really getting into that or somewhere else. So now onwards, I'm saying, somebody gets into first year, which area he is going to get into, I can give it in writing on an affidavit, he will not know where he will be landing up in. So therefore, this is something which is a matter of joy for all of us, because we don't know, but things are going for better towards the improvement in the bird scenario. Now, corrosion is what I'm going to talk about, and then I'll take you further a little more. What is corrosion? If you look at the literature, there are many definitions, mind-boggling definitions. And those who are from earth sciences, they will come across this. Corrosion is an irreversible metallurgy. Oh my God. When you look at it, even the best of the fellows will take about 2 minutes to realize irreversible metallurgy, what is it? So, best and the simplest definition, which I coined, you will not find it, is any unwanted decay is corrosion. Anything that you do not want to decay is corrosion. That is how I'll move further. And if somebody says, I have never seen what corrosion is, there is a wonderful enemy of yours which manifests itself in the form of a brown patch all over, on water pipes, on your cars, on your handles, on your utensils, everywhere, even on your specs, you will find that brown patch if you don't clean it. And that is corrosion. We have seen it. Everybody has seen what corrosion is. You look at the fans which you are using in your houses, on the blades, somewhere that brown patch will always be there. So that is what is corrosion. If somebody says, I have never seen, I think probably I'll say that you don't keep your eyes open to in and around what is happening. And how people are unaware of this, I did talk to some of the good IIT engineers, I'm telling you, and they said, well, we have no problems in our campus. There is no corrosion at all. I said, well, I can see so many of these. What do you do? He says, nothing, there's no problem. All we tell is, this is corroded, we dump it on one side, second gets corroded, we dump it there, we create a dump yard, then we'll tell the director, he calls some trucks and we haul them away and they dump it somewhere else. No corrosion at all, because you are replacing one part with another. But what are you ultimately doing? That corroded part you are dumping somewhere and you are causing a great amount of environmental hazard, which is, if you talk to anybody, they will tell you, ecology people are there from our department, they'll tell you what ultimately where is it going to lead us to. So therefore, I thought I'll tell that. Now, what is the cost of corrosion? This is something which is unimaginably difficult thing to calculate, because what we can do is direct loss of corrosion, direct loss due to corrosion. But indirect loss cannot be calculated. Suppose there is a power failure now and I am giving a lecture and you are all sitting here, and next 20 minutes we are not able to do anything. And that power failure happens because of corrosion. Now, you will say, well, there was a corrosion, so we probably replaced this thing, and it started working. This is a direct cost. Indirect cost is, I could not do whatever I wanted to do for 20 minutes. You all have been sitting here, whatever you wanted to do, you could not do it. This is indirect loss of the corrosion. So therefore, whatever calculations have been made all over the world, it is direct loss because of corrosion. Indirect loss has not been calculated. It varies from country to country. The more advanced the country is, more will be the indirect loss. I used to give a question to my students in MPhil and PhD that more corrosion means more advancement. More corrosion means more advanced is the society in which you are living. So what is it? You are talking about corrosion is damaging, decaying the material, and you are talking about better society. Well, if there is no corrosion, that means there is no material. If there is no material, that means you are staying in jungle. So you are in good old days, 7th century, whatever. So obviously, there won't be any progress. More progress would mean more deterioration will be there. So more advancement would mean more corrosion will also be there. So these are paradoxical statements which I am making, but that's a hard fact. So what has been calculated is, this is a very old calculation. The enjoyable part or the interesting part is the latest calculation which has been done by our Indian group, led by one scientist called Professor B.R. Dhawan, who was the Kalpakam head for a long time. And he was authorized to do it. And they calculated this to be now 7% of the GDP. Earlier it was 5.8, 6%. It will hover around that. But it's a substantial loss. Now most of you will find it difficult. What is it, sir? How much is 5.8%? Is not much. Let me tell you, I have coined another calculation I did. It is 10 rupees of 10 units of currency per person per year. That is the loss which is avoidable, which we can avoid had we been a little more careful, but we are not. And that you can understand if it is United States, they are 1/3 of our population, we are 1 billion plus, 10 rupees into 1 billion plus, 10 billion per year per person we are losing. You can imagine how staggering is this loss. It is for anybody to judge. I will not spend more time on this. Come down further. I'll take 5 more minutes where I would like your absolute attention, and after that, I will start giving you examples which you will start appreciating. Oh yes, this used to happen in my house. This happened there in that room. I never bothered about it. So such examples I'm going to give you. How it takes place is, it can be best studied in Earth's crust. First. Second is oxidation. Third is electrochemical mechanism, which I have put it here. Let me tell you, when we say Earth's crust, if you are careful and you start digging the Earth, and if you dig at the right place at the right time by some scientific means, you may land up by collecting a piece of copper, piece of platinum, maybe a piece of old gold. All that will be there. But however hard you do, however intelligently you do the digging, you will never ever come across a piece of pure iron, a piece of pure zinc, a piece of pure cadmium. Nothing, never ever you will get it. Why? The reason is they are not present in their stablest form, in the form of pure metal. They were always combined with something, and that something is the stablest form, and ultimately it goes into the earth and gets buried. That's it. Gold is very pure, very stable, inert metal. Platinum is that. So that you will be able to get. Copper also is relatively inert. You may get it if you are lucky enough. But no question of somebody getting pure iron. And when you don't get that, what you find is we get something in the combined form. That's well known. You can look at the literature, present one, old one, ancient one, whatever. Now when we get that, let's say iron, in the case of iron I'll talk about, I'll get it in some combined form, iron sulfide, iron carbonate, and then my earth science friends will appreciate by a series of metallurgical processes, I'll purify it. I'll not give you the details, it is purified. Goldsmiths do in the case of gold. So we purify that, pure iron will be useless. You have pure iron, even for a millisecond, it gets oxidized. So whenever we ask for pure iron to Johnson Matthey from Switzerland, they will give it in a casing, vacuumed casing. The moment you take it out, it will be iron oxide straight away. So when it is iron oxide, that means part of it has already gone. It is corroded. That is oxidation. So pure form, when we extract, it is useless for us. What we do is we alloy them, we combine them with certain other elements, and then convert it into whatever we want. If I convert iron into steel of the required properties, probably then I'll change it to a drain pipe or halafa shape or a car body or whatever I want. That is stable. That is stable for certain length of time. After that, you will find when you use in the atmosphere with moisture and other ions being present, it will interact and it will gradually collapse. And that means it will corrode. This is in the Earth's crust. Oxidation is it reacts with the atmosphere and it will obviously oxidize. And the moment it oxidizes, it loses its own character. It will not be that. And then electrochemical mechanism, you don't have to strain. I'll tell you very simply on that. And that's what you need to remember. So this is corrosion. Two methods I have explained. Third, I'm going to talk about in a very simple way, because there are people from English, people from other subjects, they'll say, why are we being bothered about it? Ultimately, it is this particular part which you will be making use of. So third is electrochemical mechanism. Let me give you very briefly. Let me tell you, every metal would tend to decay. And decay of metal is losing electrons. Don't bother about what electrons are for others. But losing electrons that is corrosion. It loses electrons. And every metal has a different tendency to lose electrons. Some will lose very fast. Some would take time. Sodium, for example, it is so instantaneous that it will just, you put it in water, there'll be a blast so fast. But there are certain which will be very slow. So this way, something which is going to be very fast in losing electrons, and the other one which is very slow in losing electrons, if I combine, I need your indulgence only for a minute. I have given you an example here of copper and zinc. You put copper in one solution, copper sulfate, zinc in another solution. Copper will lose electron relatively more slowly. Iron will lose very fast. So if I join them, iron will lose electrons and zinc will gain those electrons, and zinc will lose electrons, zinc loses faster, iron loses slowly. So zinc will lose electrons, it will travel through that circuit, and iron will capture those electrons. Ultimately, if you leave it for a while, an hour or so, you will find that zinc rod would have got eaten away completely, and iron rod would have got the whole iron deposited on it from the solution. This is corrosion. I don't need more scientific explanation. Simplest way I have told you this. This is what you need to remember, and I'm going to tell you that somebody who has never studied science, how are you going to make use of this concept? I'm going to explain that. So when I look at it, for my chemist friends, they have been teaching electrochemistry, laws of electrolysis, dilute solutions, concentrated solution, Debye-Huckel theory, all those things, and people will sleep, people will beat their heads, especially those who are organic chemists. What is all this? Why they are teaching this? Well, that's about it. I don't want to bore you with more of this. So if you look at this, it is the anode that is going to be corroding. Zinc is anode, and copper is cathode here. In a dry cell, in a battery that you use, in a radio or electric current that you give it, the wires that you join, one side is positive, the other side is negative. Positive side is electrode, negative side is cathode. That much you remember, because dry cell everybody has used. There are two terminals. So please remember, the cardinal principle that I'm giving you is, a line that you need to remember is, it is anode that is going to be corroding, cathode is going to be protected. Cathode will get protected, anode would be getting corroded. That is all you need to remember. No more science I am going to introduce, no more electrons, no more cathode. Please remember, anode will corrode, cathode will get protected. Now those who have been teaching chemistry and these aspects, they would have never told their students, or you talk to chemistry students, oh, anode corrodes, we have never heard of this. We have never read it in any book. That is what it is. But this is unfortunately not mentioned and not conveyed. Anybody who has taught, anode corrodes, cathode gets protected. I am repeating this because when you listen to the religious sermons, the saint who sits on the top and starts talking about, one repeats again and again, God is one, you have to do this. So anode corrodes, cathode gets protected. Now, once more if I repeat, you will say, what the hell is this? What is wrong with you? Why don't you move on? This is what we hear in the religious discourses. We say, we know it, move further. But the purpose of telling that is repeatedly and loudly that it gets imbibed into your mind that yes, there is unforeseen force. This is what I'm talking about. So anode corrodes, cathode gets protected. Nothing else. Please remember this. No more, and I'm going to take you further. When you look at, now this is rule of thumb. When I was giving a lecture somewhere earlier, I said, please remember, those who do not understand, those who have not followed whatever I've said, those who are not from this subject, please remember, anode corrodes, cathode gets protected. I'm again repeating and you're getting bored, I know. So I said, please remember, whether you have understood or not, what is the science behind this? Please remember, this is what I call it as rule of thumb. Right or wrong, whatever I'm saying, accept it. This is what is called rule of thumb. And rule of thumb is, that man will give it who says, I am the one, I am the Supreme Lord, accept what I'm saying. So rule of thumb here is, anode corrodes, cathode gets protected. That's it. Now what you are going to be doing, you will be trying your level best that no anodic regions are created wherever you are. The moment any anode is created, that shall lead to corrosion. That is what you need to avoid in all your daily life practices. This is what I'm going to tell you, and you will find, oh yes, we have seen this. When we do this, another interesting part, when I was talking about it, students went to, as per the habit, they went and Googled it, rule of thumb, rule of thumb. They said, sir, we checked all over Instagram, this, that, all social, nothing like rule of thumb. Where is it? No book mentions it. So this is what I'm saying, blindly following something. There is nothing like rule of thumb. I am telling you whether you have understood or not, please remember, anode corrodes, cathode gets protected. Maybe I'll be repeating this some more times to highlight what I want to say. But then, let me also tell you, negative and positive, two electrodes, anode corrodes, cathode gets protected. That is well taken now, probably you will remember. But such discrete cells are not there anywhere. You will never see, oh, this is anode, this is cathode. No, you will never see that. So therefore they are not there. Now if two metals are not there and if two areas are not there, positive and negative, why should there be a corrosion? If they are not there, why should single metal be corroding? If that is so, single metal should not corrode because there is going to be no two areas, positive and negative. But that also corrodes. I'll take 2 more minutes before we start our lecture in Shatabdi speed. When you look at it, let me tell you, look at this surface. When you look at this surface, it appears to be very, very plain, absolutely plain. But in reality, when you look at it with a microscope, you will find there are a lot of aberrations on this. It is not fully smooth. And physicists who are there, they will also bear me out that 100% plane surface is never available. 100% planarity is never achievable. Some irregularity will be there. And when it is some irregularity on the surface, you will find that those areas will interact with the atmosphere to a different extent. Wherever it interacts to a lesser extent will be anodic. Wherever it interacts with a greater extent, it will be cathode. That's it. This is what you find everywhere. Now if you say, I'm going to avoid all this, you look at this building, look at this wall. There are many irregularities on the surface. And this atmosphere that we are living in, air, it will interact to a different extent. So wherever it is interacting lesser, it will be anode. Wherever it is interacting more, it will be cathode. And anode is the one which will be corroding. The classic example will be any bolt you take, unbolted, underneath you will find it would have got corroded. It will leave a mark of that bolt, permanent mark. This is corrosion. So this is all over there. So it is not only the requirement of two metals, it is not only the requirement of two areas. These two areas automatically develop because of a differential interaction with the atmosphere. That is the reason that on our skin also, when we wash, what do? You would have noted this. We apply moisturizers. And we not only apply, we rub it very thoroughly, and then we try to see whether it is plain enough. If it is not, we apply a little more on this. Reason for that is that there are irregularities here also in the skin. And when we move, we interact with the atmosphere, our skin will get it. It will interact with them. Wherever there is more interaction, it will be anodic, lesser anodic, other side will be cathodic. Anode will start getting corroded, and your skin will start losing moisture. And you will find, if you don't take care of your skin, you will find you will develop wrinkles. And you still don't take care, it will have permanent wrinkles. This is the reason that some people who take good care of their skin, it is corrosion free, wrinkle free, and they look very young, very smart, very handsome. And others who don't bother, who are always busy into research, reading, doing work, they will have permanent wrinkles all the time. And whatever you may do, you can never do that irreversible action of bringing your skin back to that. That is the reason when you find a child, the skin is so lovely, you feel like cuddling him, picking him. And you look at a 90-year-old lady or male or female, the whole skin will be sagging, it will be full of wrinkles, and you don't even feel like having a look at it. And that's why our old friends in the family will say, please sit with us, talk to us for 5 minutes. But what you do is anybody's guess. I don't want to tell you. That is also corrosion. To avoid that, what are we doing? We are applying some kind of a coating on our faces. And this is particularly visible when you don't put it on your lips in the winter season. Third day, you will find it'll become so hard. And if you still don't take care, it will develop cracks. And once the crack develops in the lips, I will not say how hard you find to talk. And if somebody makes you laugh, instead of laughing, you start crying because it pains a lot. So this is also corrosion. And please keep counting what you are going to save ultimately. If you don't take care and you do take proper care, where exactly you are going to be leading to. And if you develop wrinkles, then ultimately what you do is you spend thousands of rupees going to some skin specialist who will pull your skin, and there are ways now these days, and they'll make you look younger again. That is what is called antioxidants. It will reverse the oxidation process, and that is what you find ultimately. And how much money you are going to be spending, I leave it to you people. So this is what I said, and if I move on further, I said single metal also corrodes, and if somebody doesn't believe in that, I coined an experiment which is not there in books, but it can be shown in 25 minutes, 20 minutes in any lab. Take a pure iron plate. My thing is not working. Take a pure iron plate. The side elevation is this. Front elevation is going to be this. And on that, you put a drop of water, 1 drop of K3FeCN6, and 1 drop of phenolphthalein. These are agents which are available in the chemistry lab. When you do that, you will find the drop in the center. The drop looks like this. So in the center, very less oxygen will go into this. On the sides, more oxygen will impinge into this. So this will be with less air, it will be anodic. This will be cathodic. Anode corrodes. It's a pure iron. So iron will start corroding. It will start coming into the solution as Fe+2. And this Fe+2, chemistry friend will know, with K3FeCN6, it will immediately give you blue color. So this moves, this is positive, will move toward negative. It will get oxidized to ferric also. And this is cathodic, it will move to this side. And on the way they interact. And it is water, incidentally. Hydroxyl ions are there. And hydroxyl ions in presence of phenolphthalein will give you pink color. So you will find in about 20 minutes time, at the center there will be a blue color. On the sides there will be a reddish color, red circle. It can be seen very clearly. And at the juncture of these two, there will be a compound called rust, which is a mixture of ferrous, ferric, various kinds of oxides, hydroxides. I will not explain all this. But there are about 23 oxides and hydroxides which have been identified. Combined together, this is what is called rust. This is what you call rusting. This is why we say iron is rusting. We never say your brain is rusting. It's a wrong terminology. Floor is rusting. Table is rusting. We'll say table is getting corroded. Floor is getting corroded. Your mind is getting corroded. So this is the way. But when iron corrodes, we say iron is rusting because the compound that is formed is called rusting. That's about it. No more of science. I thought I'll give you this because this is what I designed and started showing to the students. And they started believing, yes, single metal also would corrode. Let's go further. When I look at any book, you will find there is a certain order of the metals which will tell you which is going to lose electrons faster and which is going to be stabler. When you look at it, you will find this lithium will be on top, lithium battery we talk about, and at the end will be gold, platinum, copper, etc. They are very stable, so they will not corrode. Now let me give you a simple 2 into 2 principle. Whether you understand any science, chemistry or not, you need not. Look at this table. It is called electrochemical series. It is there in all chemistry books. Open Google, you will get this. Now when you have to protect anything, please connect 2 metals. Let's say I want to protect iron. So I will connect it with aluminium. The moment I connect these two, this is anodic, this is cathodic. So this aluminium will corrode, nothing will happen to iron. This is what I want you to remember. I want to connect zinc and magnesium. Magnesium will corrode, zinc will not corrode. This is the cardinal principle, please remember. Nothing else now. Let's go further. Let's go back for a minute. I'll give you some examples now. You would have seen that in the buses, your Tamil Nadu transport buses or private chartered buses that we use, same buses will be there. You notice that both buses have been bought on the same date, but this Tamil Nadu or Pondicherry transport company's bus will look like as if it is 100 years old bus after 1 year. And the private chartered bus will look like as if it has been just brought out of the showroom. What is the reason? Reason is, there are many other reasons. One of the reasons is, on the sides of the buses you would have seen, there is an aluminium plate which runs around the body. And on that aluminium plate, there is a rubber roller put on that. That is only for beautifying. Aluminium has a role. When I talk to the brilliant engineers, I am not joking, I am not exaggerating. When I tell them why this has been put, they will say, sir, it is to beautify. Aesthetic sense. Looks very nice. It is not that. It is the anode which has been put in connection with It is joined with cathode. So cathode will be protected. The whole body is cathode. Aluminium is anode. So that is the one which will corrode. And after 5-6 years, you will find that strip would have got eaten away. All we need to do is remove that strip and put a fresh one. That's it. And you'll find that this bus will be very new, and that is what you find in private buses. They take care of that. But in state transport buses, what you find is some fellow who is fond of drugs or drags or whatever, he will just pull that aluminium strip out, sell it to a junk seller, earn some 10 rupees, and buy some cigarette or something. And nobody bothers that aluminium strip has been removed. We should put a fresh strip. That bus will be without strip for years, and it will corrode very fast. So it will start rattling, and the result will be that bus after a year looks like as if it is 10-year-old. Everything rattles other than the horn. Horn will not work. Rest everything will work. It will make you a lot of sign. This is the reason for this. Simple thing, we need to be very careful about it. Bajaj scooters we used to have, all of us, and you would have seen some people will have scooter 10 years old but beautifully kept. Others, after 1 year, it looks like as if it is a 100-year-old scooter. Reasons are there are aluminium strips. It starts rattling, and when it rattles, people touch. Oh, this is the one which is rattling. Instead of tightening it, they remove it. The moment you remove, you have caused the death knell. The corrosion will start, and that's about it. So after that, how fast it corrodes, the paint swells off, blisters are developed, and gives a very obnoxious look. Now you will tell me the present day scooters, the present day cars, Fiats and Ambassadors used to have this aluminium strips. Present day cars and present day scooters do not have that aluminium strip. What is it? How are they prevented? Have you ever thought of it? We have never bothered. You ask anybody, they say, well, the paint is very superior quality. Well, paints are there. I'll talk about paints also. But what we find is the paint which is used these days is vacuum painted. Powder coated, vacuum painted. Powder coated is a coating of powder which is given, which is so smooth that there is no probability of two regions being developed. Very plain surface. And on that, we give coating in vacuum. So there is a uniform air entrapping under the paint. So no question of less air or more air. So no anode areas will be there. So paint stays very stable. And that's why these days, very colorful scooters you are getting, yellow, green, wonderful combination without any corrosion. This is the reason for that. Now I'll come down to your whitewashing. You all do. You all make houses. You all do the whitewashing. I'll talk about my university as well. When you do the whitewashing, how many of us have ever bothered to remove the earlier coating of whitewash? None. I'm telling you with a challenge, none. What they will do is, somebody will come, if a person like me will be there, no, remove it properly. Yes, sir, I'll do it. So we'll start with an emery paper, and the moment I'm moving out of the room, then he'll say, start painting. So they won't remove. Result is, the earlier paint is there, whitewash. You are putting another one on it. The one which is earlier one has already got air entrapped underneath. Now when you are coating the fresh, there are air entrappings, but this will be having different one, the other one will be there, you have not removed, it will develop anodes and cathodes, and within 6 months you will find the paint will come off. And that is what I tell my engineers whenever they do the painting, please remove the earlier coating. You look at it, you take a survey when you move out, you will find anywhere where there is a paint given, that paint is as if somebody has smallpox on the skin. That kind of feeling you will get. Brown paint which is there outside, you move your hand, you will get, oh, this surface has smallpox, because they have never bothered to remove that. And that leads to anodic regions and leads to corrosion. What do we do? Well, best is you remove. Now, removal is not that easy. You have to grind a lot. Why should we pay to the labor? We don't bother. We say, do it. That's it. And, oh, it's a university paint, don't bother. Do it. 6 months, though we'll say 5 years it will last, but fact is it lasts 6 months. We again do it next year. Next year. What ultimately it results, it is for you to calculate. What I am telling, if you follow, your coat of the whitewash will not come out for 5 years. I can give it in writing. Minimum 5 years. But we don't bother. One extra day you give it to a labor to remove that, you will have all that, but we don't do it. If you still don't want to do it, there are paint strippers available in the market. Apply that on this, the paint will swell up, then with a clean cloth, just wipe it out and give a fresh coating. Fresh coating of paint when you give it, but please remember, you need to give a primer first. Red lead they call it. You give that and then leave it for 2-3 hours, 5 hours, and then give painting. It will last for 10 years. Let me tell you one more thing. Whenever we paint here, what do? Please keep calculating how much saving you are doing, because at the end I'm going to ask you this. I'll give you my own calculations as well. So at the end when we do this, we don't bother. Well, painting is done. Let me tell you, the painting which is required on our grills, gates, beautiful designs that you make in your houses, they are all of mild steel. Mild steel means it has iron. Iron as one of the essential components. So what you need to do is, I advise and I suggest people that all those structures which are there, please give aluminum paint on it. But you are all qualified, learned people, and your painter who comes is a 8th class, and he tells you, sir, your building is brown, let's give brown paint on this. This is yellow, let's give yellow paint on this. You listen to that fellow, and what he tells is the best paint is a velvet paint. It is new in the market, it is going to cost 11,000 rupees, 1100 rupees a liter, let's do that. And you, very wisely, qualified person, learned fellow will buy 1100 rupees paint and do that. Result will be, in a year's time, it will come off. Where is the need for all this? Instead, if you take aluminum paint, the cost of which is about 70 rupees a liter, and you paint on that, it will be beautifully shining like silver surface, and the cost will be 70 rupees a liter, and you need not have a painter doing this. You can take your hanky, put it in this thing and start doing it this way. It will give you same get-up. So why don't we do that? We don't do that because nobody has told us. We don't do that because painter tells us, no, velvet paint, brown color, yellow color, whatever. Aluminium paint is like silver. Beautiful luster it gives. But suppose if somebody has an allergy to that, no, I'm not going to do this. I want to have yellow only on this. Please follow my advice. Take yellow paint, whatever quality of paint you are using, add 100 ml of aluminium paint in that. Will not cost much, 7-10 rupees, that's it. Mix it and then do the paint. You will find the life of that paint will be enhanced by 5 times at least. So this is in your residences when you go for the whitewashing next time. Misnomer whitewashing, we don't do whitewashing, we do all kinds of color combinations, especially in Pondicherry. But then that's the word we use. Let me give you some more examples before I move further. On water pipes, there was a lot of cracks, there was a lot of corrosion, and because of that corroded area, it will become very weak, and because of the pressure of water, it will burst. And bursting of water pipes used to be seen earlier on very many places, particularly in hilly areas, because the water runs through very difficult terrains, and whatever is buried, that will be corroding faster, so there will be water bursting, pipe bursting. So here now what they do is they wrap magnesium wire at a distance of half a kilometer, and it is the magnesium which corrodes. They just remove it after periodically and put it that way. No problems of pipes getting corroded anymore. It used to be, it's a thing of the past now. Let me give you one more interesting example, magic metal. We used to go to the fairs, and I have seen a lot of people buying magic metal. There is a lump of metal they give it. They said, you take it, it is costing 700 rupees, put it in any enameled container, put some sodium carbonate or something. They give a material, they say it is called churan. So put this metal in an enameled container and put this churan inside, and then you can put all that you need to clean, copper utensils or any other kind of utensils, or your ornaments, gold ornaments, silver ornaments in this. Leave it for a while, and you'll find they'll be clean, and just take it out. Now you feel very thrilled, oh, very good, magic metal. That magic metal is nothing, it's a lump of magnesium or a lump of aluminium. That lump of aluminium is there in your houses in abundance, your pressure cookers. You can take that, put some sodium carbonate, boil a little, heat a little, and then put the things to be cleaned. You'll find the way it gives you shining luster. That's what it is. But we don't do that. We prefer to give it to somebody who comes to your house. I'll clean the jewelry. So he cleans, charges 100 rupees, and in the process takes away 100 mg of the gold also. You feel thrilled on that. We do that because we are all intelligent, learned, educated people. Then you will tell me that if we look at the food items, jams, juices, why is it that there is a coating of tin inside? If I take you back to the order of the metals, which are this one, you will find here that it is tin made up of steel, and there is a coating of tin given on this. Tin is here. So when I look at it, it is the iron which will corrode, tin will be protected. So you'll say, why do we call it tin food, and why do we give a coating of tin? If you have to protect the life of that, we should be giving a coating of zinc on it. Well, if you give coating of zinc, zinc will corrode, iron will be protected, but when zinc corrodes and zinc comes into your juices, pickles, jams, it is anybody's guess, zinc is highly poisonous. Then instead of becoming healthier, you will be landing up in some cremation ground very soon. So that's why we don't do it. What we do is we give a coating of tin. Tin will corrode, so tin will be protecting, iron will corrode. But if iron goes into your food, juices, jams and all, iron is one of the essential minerals that our body needs. So what you have to use, don't blindly follow what I've said. What is the application, that also has to be kept in mind. And on the money part, whatever you are saving, keep calculating, because when you go to a doctor, what he charges, that is indirect cost. I'm not calculating that. Now, various forms of corrosion I've just enlisted here, you need not bother about it. One specific kind of corrosion I have not put it here. It is anybody's guess. I call it corruption corrosion. And that is something nobody can help us out with. Prevention of corruption corrosion is nowhere it is possible to the 100% extent. Now I'll tell you about the methods of protection. I'm not going to give you details. Method I've already given you, paint, coatings. So the best is anything to be protected, make it cathodic. Anything you don't want to get protected, make it anodic. That's the cardinal principle you will remember, and things will be taken care of. And then last is use of inhibitors. There are certain chemical compounds which our chemistry friends will appreciate. They have some delocalized set of electrons, and they will go and tend to block either the positive side or the negative side. If any of these sides is blocked, there will be no electrons available to move out. So the corrosion will be minimized. The word which is coming out of my mouth repeatedly is corruption. It is corrosion which will be minimized, and your problem will be sorted out. That's about it. I'm not going to indulge in any more science, any more talks on this. So therefore, whatever I said, that 30% saving you will have at the end of my talk, I don't know how many of you have calculated. It is more than 30%, let me tell you. And I have also not counted, when you get your house painted, how much man-hour you waste. Then let me tell you one more. When you are moving into your house, after day's work, when you go back, you find while going to the kitchen or taking bath, in the sanitary fittings, you will find a brown patch would appear. That is this onset of corrosion. But we don't do it. We keep shaving, looking at the mirror, and brown patch. Second day it will be a little bigger. 3, 4, 5 months it will grow into a huge piece. We don't bother. We keep doing our work. But then ultimately, that is the one under which corrosion has set in. That part would become so weak that it will start leaking. After that, what do you do? Oh, this is leaking. So you'll ring up somebody will come, he'll remove the whole pipe. Rather than doing all this, why can't we take an emery paper, and the moment you see that brown patch, like wherever you see rat, you immediately take measure, isn't it? Remove that, rub it off, brown patch will vanish, and immediately take any oil that you have, other than kerosene oil. Take any oil, mustard oil, linseed oil, or any eatable oil that is there, you apply on that. That's it. Leave it for a week, 10 days. After that, when you are shaving and coming again, put some oil again. No corrosion will be there, and it will last much more. But if you can find some time, go to the market, take about 200 ml of aluminium paint, won't cost more than 15-20 rupees. India is the third largest producer of aluminium. And aluminium in our country is very cheap, let me tell you. We are getting aluminium paint for as low as 50, 40, 70 rupees a liter. This is on the higher side. Had we been a little honest in our approach, we would have bought it at about 20 rupees a liter. So take that, and wherever you find this brown patch, apply that aluminium paint. It will look aesthetically very nice. It will save your sanitary fittings, and you will not have to replace it. But if you don't do it, this will also be required to be replaced. You will say, is that all about the corrosion? Are we this much? Well, it is not this much. We have been brilliant in our olden days. We have designed certain steels, designed certain structures, which have been absolutely corrosion-free. Iron pillar near Qutub Minar is one, which is standing for centuries, no corrosion. People have tried to copy that, they have not been successful. There are many such pillars. Sarnath pillar is one which is corrosion-free. Then one of you might tell me, oh sir, it is by fluke that they would have made this kind of an alloy. You can't design it again. If that doesn't satisfy you, there are at least 300 cannons. If you go to old forts, Jaipur or Mysore, any old fort you go, you'll find cannons are there, shining cannons, and they are corrosion-free. And they are all 400, 300 years old. Naval establishments, if you go, they are all on the sea coast, but those cannons are rust-free. Who has designed it? We have designed that with our own techniques. So they are all corrosion-free. Why can't we do that kind of a thing now? Well, it is being done, but the cost factor has gone up. There is a thing called, there is a special variety of steel.
What steel?
No, I'm forgetting the name. Anyway, that steel is one which doesn't corrode. There is a steel where you add molybdenum, it becomes corrosion-free. Now, a couple of other interesting things before I wind up. We all have seen Taj Mahal. Most of you would have seen. Anybody who has not seen, you can raise your hand. Anyone who has not seen Taj Mahal, I will advise you to do it at the earliest, because Taj Mahal, in the last a decade and a half, it has started becoming pale yellow. And by the time you decide to see 10 years from now, it will not be white, it will be creamish. People will call it yellowish Taj Mahal. People have started blaming vehicle traffic. There are gases which are emitted, CO2, SO2, and it is on the bank of a river, and it combines with them, gives you sulfurous acid, and it is all marble. It reacts and gives you this. Well, this is one of the reasons, there is no doubt about it. People start blaming the industry. They said there is a lot of leather industry in Agra and they produce toxic gases that is affecting Taj. So they have closed the industry. I am giving you a startling fact which you will not appreciate. I've written an article on this, and I was threatened after that. I said, well, hell with this, who cares? So then they say it is leather industry, they closed it, they shifted it out. They said the vehicular traffic, they stopped it. Now no bus or car can go up to a distance of 1 kilometer. Then you have to walk or use some other battery bus or something. But still, the problem has not been sorted out. Taj is getting deteriorated. And maybe 5-10 years from now, it will not be one of the wonders, let me tell you. This time also we got it with a great difficulty. Reason for that is that there is a refinery they had set up in Mathura. Huge oil refinery. There is no oil anywhere near Mathura. Oil comes from New Bangaigoi in Assam. So oil is transported to this place. Then that crude oil is purified. And when that happens, there is a lot of CO2 and SO2 which moves from Mathura to Agra side. Wind blows this way. And they say, politicians say, no, it is a job giver, it is this, it is that, industrial growth, all kinds of things. I'm not getting into the details. Fact is that is the factor which is responsible for corrosion of Taj. What can be done? We suggested, I was a part of that committee, we suggested that the whole Taj be coated with an epoxy paint. It is possible. In Manchester, people have done it to save their buildings. We can also do it. But the other experts There are experts I will say do this, others will say, oh, Gurmeet is telling this. No. We'll not do this because it will lose its luster. Yes, on full moonlight, you will not get the luster that Taj gives you otherwise. But they say, we want the luster to be there. What luster will you get when it will not exist there? What luster will you, when the structure is not there, what luster? So most important is to prevent our structure, to prevent our monument from decaying. And this is the reason. But if somebody says, no, we'll reverse the direction of movement of air. Instead of from Mathura coming to Agra, we'll send it to Delhi. Delhi has enough pollution otherwise. It will not accept. But can you do it? Can you change the course of river unless it does on its own? You can't do it. So these are befooling techniques which some of our so-called modern monarchs will give it, and we accept it. We have written, I said, no, this is not the thing. Allow vehicular traffic, let the industry be there. That is not the cause for this. Cause is something else. We need to check on that. But now you can't close that refinery. What you need to do is give an epoxy paint. Save Taj. That is important. Maybe next campaign which we'll launch would be Save Taj. Let this be one of the wonders of this. There are many other examples one can always talk about. And you use cooking in your houses. And what you do, unless our food is fried and we add a lot of masalas and we destroy the generations of the vitamins which are there, we don't enjoy our food. Every oil has vitamin A and D. But do we allow that vitamin D to remain as vitamin D the way we cook? I mean, the 3 generations of vitamin D will not remember that they were vitamin Ds. So what you find is, we need to add ghee at the end. When you cook, then you add, so that vitamin stays. And corrosion will also be avoided. But we don't do that. We do cooking in that aluminium, and we put a lot of lemon also at times, and that reacts with the material. So the safest thing these days is to use either non-stick or use anodized aluminium utensils. Anodized aluminium utensils are available all over now. In fact, normal aluminium utensils are not available now. Gone are the days. So anodized aluminium is when you get a multi-layers of aluminium oxide deposited on this. That will be absolutely corrosion free. This is called resistive layer. And you do anyway. You put masala, you put acid, you put anything, it will be corrosion free and your food will be safe. So, and non-stick when you use, obviously, it has a epoxy layer which will be safer for you to cook any way you like, veg, non-veg or whatever, or rasam or sambar, whatever. That also has a lot of material which is toxic, reactive at times, but safer for us. So that's about it. This is what I thought I'll tell you in the first part of the talk that I thought I will be delivering. Second part could be on the electrochemistry for energy storage material. In a similar fashion, I'll tell you what is the simplicity involved in this. It is not a difficult thing. Let me finally conclude. Whenever you talk to anybody, I have used all this material. I said we use certain compounds which will block either positive side or negative side. And once they block, corrosion will be prevented. Those blockers are called inhibitors. And my entire work on corrosion related area is on corrosion inhibitors. Very simple, good work, quality work, useful work. But let me tell you, whenever anybody gives a lecture, I am saying anybody, many scientists are sitting here, they always say, oh, you want to do work in this? It is very difficult. Don't get near this. Impossible for you to understand. Not difficult, not easy. Don't venture into this. But let me tell you, wherever I have given a lecture, wherever I have gone, I tell them, this is the easiest way to start research in, best way to publish papers, without any resources. You don't have anything, come to me, I'll explain what you do. And you can within 6 months come out with an excellent paper. So it's very easy to do it, simple to do it, very useful for the society as well as for your own houses where you can save a lot of money. So we used to buy, in good old days, 76, I bought from Professor Feller's lab, Wanking potentiostat from Germany. And he said, you can't afford, I'll gift you this. And believe me, when that gift I brought it to the airport way back in 75, 76, the kind of a hell I had to go through. with the custom telling me what is it, commercial value, this, that, get this certificate. It took me 2 months to get it released during those days. Then we started working together and we did good work with that instrument. It used to cost about 3 lakhs in those days. Now, similar kind of a thing, electrochemical systems, which chemistry people will have, will cost about 14 lakhs. But what I've explained, movement of electrons and current, you can do the similar kind of a work with a dry cell, a voltmeter and an ammeter, which physics people will have it in plenty. And the costing, if you do it, will be about 300 rupees. Nothing else. Only thing is there, it will be computer which will be giving you reading. Here you will manually do everything, put it on the graph, but similar results you will get it. Therefore, research in corrosion can be done by each and everybody without spending much money on that. And what I have explained, with the help of some electronic engineer, we designed this potentiostat. Now you can get it made with the help of any electronic technician here for about as low as 5,000 to 6,000 rupees. And you can carry out the entire set of work with this. Therefore, if you say, I am doing a remarkable work, I have done nothing doing, it's a very simple work. Any individual can do it. So if you have not started any work in the area of this, high time you can start here in Pondicherry and get the good publication. That's all about it. I leave it for the time being. And if you have any questions, I'll be too happy to answer. Thank you very much, please.
Thank you, Professor, for your very interesting and very interactive talk. So before I thank, I would like to give the glimpses of the talk. So the talk, Professor started to introduce the electrochemistry, and then electrochemistry of the material science, and then bioelectrochemistry, and then environmental electrochemistry also. Then he talked about the LED. Then the major talk of the major subject of the today's talk was the corrosion, and then electron loss of corrosion also we discussed, and electrochemical mechanism of corrosion also. It was very important portion is electrochemical corrosion of the electrochemical mechanism of the corrosion. The very important was that rule of thumb. So this is very useful in our day-to-day life. And anode corrodes, cathode gets protected. This is very useful. You can apply, because some of the very different example he didn't explain also. So when I attended the this refresher course, he gave a talk during the, when I attended, he was giving the talk during this time. Once he finished the talk, there were 50% of people going behind him. Sir, please tell this, like this. So that was the very importance of this talk. Because once he told how to protect because in Delhi the cooler was very famous. So once you buy the cooler, only it lasts for 1 or 2 years. After this we have to go buy fresh cooler. So how to protect cooler? He used to explain those days how to use the.
You tell them I have a cooler which is 25 years old.
Yes. So in his home he used to tell, even 25 years this cooler is still working, because he buys zinc and apply put the zinc every year. He changes only zinc powder over this one. That's all. His cooler is getting protected. So these are very useful tips he used to give. The simple logic is the anode corrodes, cathodes gets protected. So then electrochemical series also he gave. This is, as he said, this is very, you can get it in the Google. So you just say whatever the material, whatever the metal you use, so how to protect, use the previous one or the previous any other metal to safeguard the whatever the metal you use. Very simple mechanism, but most of us we do not pay attention into this. So it says, as he said, a lot of money he didn't generally give. He generally gives how you can save 30% of your budget by understanding the corrosion in day-to-day life. So I take this opportunity to thank our Honorable Vice-Chancellor to give the very interesting talk. Also to choose his time. I know how difficult to get a time to give a public lecture for a Central University Vice-Chancellor. he immediately agreed, and he gave the talk. You can see even he stands for more than 1 hour. So after all of you know, he had during second wave he had a corona also. During this, after this, he difficult to stand for longer times. In spite of this, so he delivered a talk. So in this, on behalf of all of you, I thank our Vice Chancellor to give this very useful talk. Thank you very much.
But one final golden rule: if you want to absolutely protect anything, don't buy. That's it. That's the safest way. So you will have no problems at all.
Honorable Vice Chancellor, Directors, Register, Finance Officer, Deans, Heads of the Departments, Faculty Members, Supporting Staff, and my dear students, good evening. I feel honored to propose this vote of thanks on this occasion. I would like to thank our chief guest and the subject expert of today's popular talk, who is none other than our own Vice Chancellor, for sparing his valuable time for us and gracing this event. I am sure your thoughts have motivated us, especially the younger minds who are watching this event online through the video streaming. Further, I would like to express my deep sense of gratitude to our director, Register, for making great efforts to make this event very successful. Next, I would like to thank our technical support team, the people in the engineering wing, computer center, and especially Dr. Arul Shelvam from the electronic media department for facilitating all their support for video streaming and other facilities. I would like to express our gratitude to our known and unknown hands who have contributed directly or indirectly for making this event highly successful. And thanks to one and all, and I would like to take your leave with a feeling of happiness and gratitude. Thank you.